Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the numerical based on the decay constant problem number 17, and now we are going to talk about the problem number 18. So let us find out what is the question that is and what is the required data that we need from this question. So friends, the question which has been given here is: a sample of old wood shows 7.0 dps per gram, that is disintegration per second per gram. If the fresh sample of the tree shows 16.0 dps per gram, how old is the given sample of the wood? And the half-life of the carbon-14 is 5730 years. So this is the question which has been provided to us, and let us see that is what are the data that has been given in this question. So before understanding what is the data, let us understand this question first. They have provided us a sample of an old wood, and that has a disintegration per second of 7.0, while the fresh wood or the fresh sample of that same tree, of the same wood obviously, then it would be, that is 16.0 dps per gram. So in that case we could say there are two conditions which has been given to you. That is, the first one is the sample of the tree obviously which has the disintegration which is higher compared to that of the old one. The reason behind that is the new tree, obviously the original sample, it consists of a disintegration per second of 16.0, while that of the old wood shows 7.0 dps per gram. So in that case, so here we have initial disintegration per second of 16.0, while here we have 7.0. So from this data we can easily estimate how old the given sample of the wood is. So here the half-life of the carbon has been also been mentioned, because the wood obviously it consists of carbon, so that's the reason the half-life of the carbon has been given here as 5730 years. So based on this all data, let us see how we can find that how old the given sample is. But before that we have to write the given data. So the data which has been given here is, we know that is the disintegration per unit time, obviously, that is d n naught is been given here as 16.0 dps per gram, while that of the old wood, it has, I could write it over here as minus dn upon dt, which is found to be 7.0 dps per gram. So these are the two data, but along with that we also have the half-life for the carbon-14. So for that we have T half, which has been given to us as 5730 years. So based on this data we can easily estimate, that is the decay constant, that is lambda. So let us find out the lambda first, and then we'll talk about the time required to convert 16.0 to 7.0 dps, that is disintegration per second. As we already know, that is T half has a formula, that is T half is equals to 0.693 divided by the decay constant. So therefore what we have to do is we have to find out the decay constant. So decay constant is equals to 0.693 divided by that half-life. So in this case the half-life which has been given to us is 5730 years. So that means the decay constant will have a unit of year inverse. So let's calculate this thing. Let's see what is the decay constant we could get. So we have got the value 1.209 into 10 raised to minus 4 year inverse. So this is the value for the decay constant, that is what we have got. And based on this we would be finding what is the time required for the change. So let's see what is the formula. So the formula for the decay constant is lambda is equals to 2.303 divided by the time log to the base 10 ratio of n naught divided by n. So here we have the value of n naught as well as n also. So let's see, let us substitute these values, and yes, obviously we have to find out the time. So t is equals to 2.303 divided by lambda log to the base 10 of n0 divided by n. So n0, that is n naught, it has been given as 16, while that of the n, it has been given as 7. So let's see how we can calculate this by substituting the values of the lambda, that is the decay constant here also. So let me finish up with this one. 2.303 divided by 1.209 into 10 raised to minus 4 into log of 16 divided by 7. So let's see what is the time we could get, and obviously we will get the unit of the time here as years, because the value of the decay constant, what we have got is 1.209 into 10 raised to minus 4 year inverse. So this is the value that we could get in years. So let's see what is the time that is being required to convert the change from 16 to 7.0 dps per second per gram. So we have got the value, almost 6839 years. And that's it. So this is how basically we can calculate this kind of numericals. And thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.